Hello and welcome. Myself, Amudha, Assistant Professor in the Department of Computer Science and Engineering. Today, my presentation is about Bibliometric Study on Model-Based Systems Engineering, or in short, MBSE. This study focuses on the trends, patterns, and growth of research in a specific field. Today, I have chosen the research article by Zihang Li and team titled as Bibliometric Analysis of Model-Based Systems Engineering, Past, Current, and Future, published in the journal IEEE Transactions on Engineering Management. Indeed, it is a fact that in recent days, the number of academic publications is increasing at a rapid pace. Also, literature survey plays a crucial role in analyzing the past research findings. This helps us to use the existing knowledge base and advance a line of research in our specific field. Let's take a look at the flow of today's discussion. We'll begin by understanding the key metrics used in bibliometrics, followed by an overview of different types of metrics used to assess the quality of publications, followed by model-based systems engineering, its timeline, research methodology, and visualization methods. Metrics are critical tools used in bibliometric analysis to evaluate the productivity, impact, and collaboration patterns in academic research. They provide measurable insights into how research grows and influences the scientific community. The different attributes of metrics used in scientific community are publication count, citation count, H-index, co-authorship analysis, and so on and so forth. Various forms of metric analysis like Bibliometrics, Webometrics, Scientometrics, Cybermetrics, and altmetrics is shown in this Venn diagram, depicting the relationship among them. Let us see them one by one in the upcoming slides. Bibliometrics is a field of study that applies quantitative methods to analyze academic publications. It focuses on tracking the number of publications, citations, and research trends to evaluate the scholarly impact of researchers, institutions, and entire fields. The term bibliometrics comes from the Greek word biblion, meaning book, and metron, meaning measure. Bibliometric analysis is particularly valuable in identifying influential research works, emerging research areas, and patterns in the growth of scientific literature. The key bibliometric indicators are total publications, total citations, impact factor, and H-index. Next metric, Webometrics. And Webometrics is the quantitative analysis of online academic content, particularly on the World Wide Web. This field evaluates research dissemination on digital platforms and measures the impact of web-based scholarly resources. It tracks web citations, links, and online academic engagement. Webometrics differ from traditional bibliometrics by focusing not just on publications and citations, but also on factors such as the number of backlinks to a university website or mentions on the academic blogs and research visibility on social media platforms. It extends the scope of evaluation beyond academic journals to include digital repositories, websites, and online research networks. An important aspect of Webometrics is link analysis, which examines the structure and connections of websites. For example, a university with a strong web presence, including numerous links to its research papers, would rank higher in Webometric studies. Additionally, search engine analysis helps measure how easily research content can be found online. Indeed, it is a fact that that are more visible tend to be cited more often. Next metric is Scientometrics. Scientometrics is the study of the quantitative aspects of scientific research. It goes beyond bibliometrics by analyzing not only on publications and citations, but also the broader mechanisms of scientific research, including collaboration patterns, research funding, and innovation trends. Scientometrics provides insights into how scientific knowledge evolves over time and across disciplines. It is often used to identify research clusters, evaluate national or institutional research performance, and track the impact of specific research area. One key tool in Scientometrics is citation network analysis, which maps how scientific papers cite one another. This reveals influential works, emerging research fields, and historical trends. Informetrics is another key metric that applies mathematical and statistical method to study the production, distribution, and consumption of information. It encompasses bibliometrics, webometrics, scientometrics, making it a broader discipline that focuses on measuring information flow. One of the key techniques in Informetrics is text analysis, which uses algorithms to analyze the content of research papers, articles, and online resources. For instance, text analysis in MBSc research might reveal recurring themes such as digitization or safety analysis. By analyzing the frequency and context of these terms in publications, as we are more often come across the word term frequency in text mining. Informetrics also examines the efficiency of information retrieval systems such as academic databases and search engines to improve access to scientific knowledge. This is especially relevant in today's digital era where researchers rely heavily on online resources. Next metric, altmetrics or alternative metrics measure the impact of research beyond traditional citations. Unlike bibliometrics, which focuses on academic citations, altmetrics track engagement with research on social media, blogs, news outlets, and other digital platforms. This reflects the broader social impact of scientific work. Altmetrics provide real-time insights into how research is discussed, shared, and debated online. For example, if a paper is widely shared on Twitter or discussed in a popular science blog, it would score high in altmetrics even if it has not been formally cited yet. Key altmetric indicators include mentions on social media, tweets, Facebook posts, and LinkedIn discussions, or news coverages, discussions on academic research or research blogs, and downloads and views from platforms like ResearchGate or academia.edu. So, revisiting our article under discussion, the core focus is on model based systems engineering. MBSc is a systems engineering approach that uses models to support the entire life cycle of a system from design to implementation and verification. The bibliometric analysis of MBSc helps us track how research in this field has evolved and understand publication trends and evaluate influential works. For example, analyzing publications in IEEE transactions on engineering management or other high impact journals can reveal research clusters, emerging themes, and key contributions in MBSc. We can examine the growth of MBSc related publications over the years and how interdisciplinary research, such as combining MBSc with cyber-physical systems or safety analysis, has gained prominence. By conducting this bibliometric study, we can answer key questions like which journals and conferences dominate MBSc research, and who are the leading researchers in this field, what are the most cited papers and influential topics, and this sets stage for a deeper dive into the history, trends, and the thematic evolution of MBSc research. Model-based systems engineering is a methodology that emphasizes the use of formal methods to improve the design, analysis, and management of complex systems. Unlike traditional systems engineering, which relies on documents, MBSc uses models to represent system requirements, architecture, behavior, and mood. MBSc has gained popularity due to its ability to handle complex and multi-domain systems such as cyber-physical systems, autonomous vehicles, and aerospace systems. MBSc improves system understanding, reduces errors, and enhances collaboration among stakeholders. This slide presents the historical evolution of MBSc, and bibliometric analysis often includes creating a timeline to track key milestones such as the publication of influential papers, the emergence of new research themes, and technological advancements. For example, early MBSc research may have focused on basic modeling techniques and system requirements. Over time, the focus shifted to more advanced areas like integrating MBSc with artificial intelligence, CPS, and digital twin technology. This timeline helps us to visualize how the research landscape has evolved and where future research might be headed. This slide focuses on the research methodology commonly used in MBSc studies, and bibliometric analysis can help us understand the methodologies researchers can adapt to handle the key challenges. Step 1 is about the data collection, where publications are collected from various sources like Scopus or Web of Science journals. And step 2 is analysis of the relevance of the collected publications based on the author sources and keywords. This step gives the final list of publications to be analyzed. And step 3 is all about different types of analysis like co-authorship analysis, citation analysis, co-occurrence analysis, and factorial analysis, followed by the thematic map and evolutional analysis. All these steps finally lead to the future directions an author or the research team should head on to. In the upcoming slides, let us discuss about the different types of visualization analysis methods available to support the scientific research community. Visualization is the key component of bibliometric analysis. R language supports a wide variety of functionalities to support these visualization methods. The most common visualization methods are presented here. The co-authorship analysis visualizes collaboration networks among the researchers. Citation analysis maps citation patterns to identify influential papers and the researchers. And co-occurrence analysis examines frequently occurring keywords to discover research trends. Next is the factorial analysis. It identifies research clusters and thematic patterns. And thematic maps, it represents the visual representations of research topics and their evolution over time. This network shows the co-authorship analysis, and co-authorship analysis is an essential part of bibliometric studies. It helps visualize the collaborative networks of researchers, institutions, and countries. By examining co-authorship patterns in MBSE research, we can identify leading research groups, interdisciplinary collaborations, and global research hubs. This slide presents the top 10 sources of MBSE research, ranked by the total citations and the total publications. Journals with high citation counts, such as IEEE transactions, are often considered more prestigious and influential. Here, the list shows the top 10 most cited papers in MBSE. These papers represent the foundational research that has significantly impacted the field. And next, this slide shows the distribution of researchers in MBSE, highlighting key contributors, emerging researchers, and the global research patterns. The next slide provides the analysis and grouping of keywords in scientific papers. This helps us to identify the trending topics in a relevant research area, hence called as Keywords Co-occurrences Analysis Network. And this slide shows the type of analysis called factorial analysis to find similarity index in the ongoing research. For example, the red cluster shows the keywords in the main topic, and it encompasses well-established research areas such as architecture, framework, conceptual modeling, systems engineering, design methodology, verification and validation, and simulation. Also, it includes subfields like ontology, system design, safety analysis, and meta-modeling, highlighting the core research themes in the domain. The blue cluster, on the other hand, shows the potential topics such as emerging research area like blockchain, digital twin, artificial intelligence, machine learning, Industry 4.0, and IoT. These topics indicate a shift towards cyber-physical systems, decision support, and co-simulation, suggesting future research directions. Overall, the factorial analysis calculates the similarity index while allowing users to normalize bibliographic coupling, coherence, and co-citation. It provides valuable insights for academic and practitioners to understand the relationship between established topics and emerging fields. The thematic map of MBSE categorizes topics in model-based systems engineering based on their development degree and relevance. Mota themes on the upper right corner shows the systems engineering cluster drives research including systems thinking, product development, and the basic themes in the lower right shows the language cluster covers SysML, UML, and requirements engineering fundamental to MBSE. And emerging or declining themes in the lower left part of the diagram shows the digitalization cluster, digital twin, IoT, or Industry 4.0, suggests the evolving trends. And the niche themes in the upper left shows the safety analysis cluster focuses on safety, embedded systems, and safety analysis. This diagram represents the thematic evolution of research topics over time using a temporal network layout. Each time period, 1993 to 2006, 2007 to 2017, and 2018 to 2022, contains key themes with edges connecting related topics across different periods, illustrating their continuity or transformation. Some themes, such as systems engineering and requirements engineering, remain relevant across the three periods, while others, like architecture, evolve into newer topics such as system of systems and ontology. Additionally, emerging themes like blockchain and digital twin in 2018 to 22 reflect the growing influence of modern technologies in the research landscape. And I would like to conclude with the note that bibliometric analysis plays a crucial role in understanding the evolution of model based systems engineering, offering deep insights into historical progress, current advancements, and future trends. By analyzing citation patterns, co authorship networks, and thematic shifts, this approach identifies key research areas and influential contributors. The findings emphasize the growing significance of MBSE in managing complex interconnected systems across diverse domains, including cyber-physical systems, safety-critical applications, and digital transformation. Ultimately, bibliometric analysis serves as a powerful tool for guiding researchers and practitioners towards impactful innovations in the field. Thank you for your attentive listening, and I look forward in meeting you in the next presentation. Thank you.